After falling from rest at a height of 30 meters, a 0.50 kilogram ball rebounds upward, reaching a height of 20 meters. If the contact between ball and ground lasted 2 milliseconds, what average force was exerted on the ball? So that's our question real quick. It's a forces problem. Let's draw it out. So our ball's right here, right? It's at a 30-meter height, okay? It falls down, it goes back up, but it can only reach 20 meters this time. Its rebound height is 20 meters, okay? So this is 30 meters, and this is 20. Now, it also tells us that the time in which the ball was in contact with the ground was 2 milliseconds. Let's convert that to standard unit seconds. That would be 0.002 seconds. Okay, so that is our basically like a picture for the scenario, right? Now, we also know that when it's getting dropped, our change in y is going to be negative 30 because it's being dropped from a height of 30, right? So our displacement is going to be final minus initial, so negative 30. Our initial velocity, since it's being dropped, it's falling from rest, therefore it's 0. And it's traveling through the air, so acceleration is negative 9.8. All right, now we can figure out the velocity of the ball when it hits the ground, its final velocity, right? Using this kinematics formula. Okay, so final velocity equals initial velocity 0 plus now we can put that into our calculator. Oh, I meant squared here. Okay, so that gives us 24.248. And units always meters per second. Okay, so this right here is the velocity of when it hits the ground. Now, we also know that when it gets up here, right, its change in y is 20 meters, right? In the process of getting up there, and even when it gets up there, the acceleration is negative 9.8, right? And its final velocity is going to be 0. At this exact point, its final velocity is 0. Okay? This will allow us to find the initial velocity of when the ball left the ground. Okay, so we can use the same formula. This is going to be 0. Okay, I'll put that into a calculator, and you will get 19.798 meters per second. Okay, and this right here is this. Okay, now, interesting part. Acceleration is what? Change in velocity over change in time. Okay, our initial velocity in this case is this, and our final velocity is this. Okay, but you also have to realize that since the velocity includes magnitude and direction, it's a vector. This side is going down, and this side is going up. Now, depending on your frame of reference, you can decide what you want to do. So I'm just going to say that this side is positive and this side is negative. Okay? Therefore, the velocity on the left is going to be positive 24.248. The velocity on the right is going to be negative 19.798. Okay, now change in velocity equals final minus initial, and for negative 19.789 minus initial velocity, which is 24.248, divided by our time in seconds, 0.002. Okay, now acceleration turns out to be negative 22,023.85 meters per second squared. Now, if you go back to the question, it's asking for the average force. How do we find force? Newton's second law. F equals ma. Force equals the mass of the ball, which is 0.5 kilograms, times the acceleration. Okay, this gives you negative 11,011.92 newtons. Okay, and you could have also gotten a positive number there and there if you had a different frame of reference. Okay. So your final answer is this.